In this video, we'll go over a theorem with some of the properties regarding the operations of power series. Now, suppose you have the power series, the sum of a sub k x to the k, and the power series, the sum of b sub k x to the k, which converge absolutely to f of x and g of x respectively on the interval I. Then the power series, which is the sum of the quantity of a sub k plus or minus b sub k times x to the k, converges absolutely to f of x plus or minus g of x on I. So that's saying that if we add term by term the two power series together, then that sum or difference, if we're subtracting them, converge absolutely to the sum or difference of the functions f of x and g of x. The power series, if we take x sub n times the sum of a sub k x to the k equals to the sum of a sub k times x to the k plus n, which converges absolutely to x to the n times f of x on I, provided n is an integer such that k plus n is greater than or equal to 0 for all terms of the series. So that's saying that if we take the power series and multiply it by some x to some power, where again that exponent n satisfies that inequality constraint, then that converges to x to that power times the f of x. Now, for the third one, if h of x equals to c times x to the m, where m is a positive integer and c is a real number, the power series, the sum of a sub k times the quantity h of x, that raised to the k, converges absolutely to the compositive function f of h of x for all x, such that h of x is in I. So that's saying if we have take the power series composed with a function h of x, then that converges to f of that h of x. Now let's look at a few examples. Specifically, let's look at examples of the second property first. So let's say we're told to find the power series and interval convergence for x to the fifth over 1 minus x. Now, recall that 1 over 1 minus x equals to the sum, as n goes from 0 to infinity, of x to the n for values of x which the absolute value of x is less than 1. So what we're doing for this x to the fifth over 1 minus x, we're taking that x to the fifth times that 1 over 1 minus x. So from what we were just saying, that would be the same thing as x to the fifth times the power series of n going from 0 to infinity of x to the n, which would be, so we could write that out, so that would be what? X to the fifth plus x to the sixth plus x to the seventh plus x to the eighth, So that's equal to the sum, as n goes from 0 to infinity, of x to the n plus 5. And the interval convergence for this power series would be for the absolute value of x less than 1. Now, looking at an example of the third property is if we were to find the power series and interval convergence for 1 over 1 minus 2x. Now what we're going to do is substitute 2x for x in that power series for 1 over 1 minus x, because again, that 1 over 1 minus x, that was equal to the power series from 0 to infinity of x to the n. Again, our interval convergence for the absolute value of x less than 1. So the 1 over 1 minus 2x would equal to the power series from 0 to infinity of the quantity 2x to the n using that third property. So that would equal to 1 plus the quantity 2x plus the quantity 2x squared plus the quantity 2x cubed, dot dot dot. So that would be like 1 plus 2x plus 4x squared plus 8x cubed, dot dot dot. So like we were just saying, that's equal to what we were just saying before, the power series from n going from 0 to infinity of 2x to the n. And this interval of convergence in this case, well, it converges for values of x with the absolute value of 2x. Well, we're plugging into the power series in for x when that's less than 1. So that gives us the equivalent of saying when the absolute value of x is less than 1/2. So that would be our interval of convergence for that power series. Now looking at one more example of the third property, if we define the power series and interval of convergence for 1 over x plus 2, now that would be the same thing as 1 over 2 plus x, which would also be the same thing as 1 over, let me factor out 2 from both of those terms in the denominator, so that would be 1 over 2 times 1 plus x over 2, which would be the same thing as 1 over 2 times 1 minus x over 2, which would be the same thing as 1/2 times that 1 over 1 minus that x over 2. So now using that third property, that would be the same thing as 1/2 times the sum from 0 to infinity. Well, we're plugging in, and that should have been a negative, sorry, a negative x over 2, because when we factored out that negative sign, it would be negative, negative, or minus a negative. So that would be negative there. So that would equal to, what we're substituting in for the x in this case is the negative x over 2 raised to the n. And that would be the same thing, multiply the inside by 1/2, also factoring out the negative 1 to the n. This would be the sum from 0 to infinity of negative 1 to the n over 2 to the n plus 1 times x to the n. Now this would converge, so this converges for when that, what we're plugging in, that negative x over 2, when the absolute value of that is less than 1, so that is when the absolute value of x is less than 2. So that would be our interval convergence for that power series.